Okay, I'm going to find the area bounded by these two curves. Y equals square root of 3x plus 1 and y equals x plus 1. Hopefully the one boxed in red is simply a line, slope 1, y-intercept 1, so it shouldn't be a big issue to find that line. Graphing a square root is like a square, except it's a parabola, probably opening to the side. Now you can find out where they meet by setting them equal. I always put 0 into each. If I put 0 into here, I get a 1. If I put 0 into the line, I also get a 1. You can look for things that are perfect squares also, be logical about it. If you put a 3 in, 3 plus 1 is 4. If you put a 3 in over here, 3 times 3 is 9, square root of 3 is 3. 3 plus 1 is also 4, so it's going to be a parabola opening, or at least half of a parabola, opening to the right. This is the square root of 3x plus 1. And this other one is y equals x plus 1. Now, if I didn't do that, if I wasn't persistent enough to plug in enough points to find where they meet, you can always set them equal to find where they meet. So I could take the square root of 3x plus 1 and make it equal x plus 1. If I subtract 1 from both sides, I'd have square root of 3x equals x. To get rid of a square root, I square both sides. So that was square the square root, gets rid of that. Square this side gives me x squared. Again, I always make them equal 0. So I would subtract 3x, factor out an x, and notice the two x values that they meet at would be x equals 0 and x equals 3. I kind of determined that already just by simply plugging in some integer values. Now to find the area between these curves, this shaded region, I always recommend you draw a sample rectangle. So I'm going to draw a vertical rectangle just so I can determine which curve's on top. You could probably see in this case that the parabola is on top. So when I find the area, that's going to equal the integral, on this case, from 0 to 3 on the x-axis. So I'm going to integrate 0 to 3 of the top curve. In this case, the top curve is radical 3x plus 1 minus the curve that's below it, the curve on the bottom, which is the line x plus 1. And every integral needs a differential, dx. That's the axis we're integrating over. I usually give half credit for the setup, so I'm going to circle this so that I know that that's my setup to find the area. Now before I evaluate this integral, I suggest you always simplify, because usually things will subtract off or it might clean up a little bit. In this case, I have the square root of 3x, and I believe 1 and a negative 1 are going to subtract off, and then just minus x. To integrate this first one, how can I make it into u to the 1/2 du? Remember, you can do these as two separate integrals if you like. If u is 3x, what is a derivative of 3x? 3 dx. So you might need to multiply by a constant of 3 on the inside, and it's reciprocal on the outside so that you don't change the value. So this integrates u to the 1 higher, 1 more than 1/2, or 2 halves more than 1/2 is 3 halves. Dividing by 3 halves is the same as multiplying by 2/3. So I believe that's 2/9 u, which is 3x, to the 3 halves. The second one integrates a little easier. It's just x squared over 2. X squared over 2. Remembering what my u was on this first one is 3x. Now to evaluate it, you plug in your upper bound minus your lower bound. So if I was to put a 3 in, I'd plug it in. 3 times 3. Anytime you have a fractional exponent, always remember that it's power over root. And if you take the root first, you can make the number smaller and easier to handle. I'll say that again because a lot of my students resist me and try and do it the more difficult way. If you take the square root first, let's put 3 in. Well, 3 times 3 is 9. The square root of 9 is 3. 3 to the third is 27. So this over here is going to be 2/9 times 27. I'm plugging in the upper number. Minus, put a 3 in there, I think would be 9/2. Minus, when you put in your lower number or lower bound of 0, I believe it becomes 0 minus 0. Now 9 goes into 27 3 times. 3 times 2 is 6. 6 could be called 12/2 minus 9/2. So I believe this shaded area would be 3/2 or 1.5 if you were to do this on your calculator. I hope this helps. Good luck.